Hello friends, I am Aman back with another beautiful problem on binary trees, LCA, lowest common ancestor. So let's just quickly see what LCA is and then we'll have some discussion. LCA is defined between two nodes P and Q as the lowest node in tree which is an ancestor to both P and Q. So maybe let's just try to understand it by an example. This is very easy. So let's just say let's just first talk what ancestor means. Can I say this B is an ancestor of D? Yes. This A is an ancestor of D? Yes. For these nodes, E and H, A is an ancestor to both of them, right? B is an ancestor to both of them? Yes. C is an ancestor to both of them? Yes. Is D also an ancestor to both of them? No, right? So lowest common ancestor is, out of all the possible ancestors, the last ancestor at which the division happens. I mean, after which there is no more any common ancestor. So let's just try to understand it by some examples. So LCA of M comma H. LCA of M comma H. So all the common ancestors are these A, B and C. Last common ancestor is what? C. Now let's see for other examples. LCA of J comma L. So for J and L, I think if I'm not wrong, these are all the ancestors, right? A, B, C, D are all the ancestors, while the lowest common ancestor is nothing but D. Now let's talk about the last example that we have, LCA of D comma C. So for D and C. So for C, all these are ancestors. For D, all these are ancestors. What is the last common ancestor? C. I mean, that's how it's defined in the question. It's C. Cool. So when something is in the path, when they are in the same path, the upper thing will be called ancestor. Let's just say that's how they have defined it in the question. Although it's arguable that you can say maybe B. Okay, because C, how can C be an ancestor to itself? So that's a different thing. But the way it's defined in question is that for both of them, the ancestor is C. Lowest common ancestor between them is C. So the way it is defined in the question, the lowest common ancestor between them is between D and C is C. Okay. Now how we are going to do that? So in the previous question, in the previous video, in the previous problem, I have made a video on get node to root path. Okay. So let's just see. Let's just try to do it here. Get node to root path for M. This is the node to root path. It will contain what? It will contain M, F, D, C, B and A. Let's try to get node to root path for H. This is what I get. I get what? H, G, C, B, A. Now friends, you can see A is a common ancestor to both of them. B is common ancestor. C is the last common ancestor among both of them. Hence C is the answer. Cool. Let's try to do it for J and L. So node to root path for J is for J it is JEDCBA. JEDCBA. For L it is, where is L? LMFDCBA. LMFDCBA. Correct everyone? So A is a common ancestor, B is a common ancestor, C is a common ancestor, D is the last common ancestor, hence D. And let's do the same for D and C. So lowest common ancestor. The node to root path for D is DCBA. And for C it is CBA. So the last common ancestor, A is a common ancestor, B is a common ancestor, C is a common ancestor. Last common ancestor or lowest common ancestor is nothing but C. Hope it makes sense. Now this node to root path function I have already explained in a previous video. You can 100% watch that out. I'm not going to explain that here. So let's just code it up. So I have two lists. I want to get the lowest common ancestor between P and Q. So I got the path, the node to root path for both of them. What do I have to do? Simple. Let's create two variables, and I is equal to L1 dot size minus 1, J is equal to L2 dot size minus 1. Now let's create a variable previous match. So basically what I'm planning to do is I'll keep two variables, one I here and j here. Okay, they are matching, move ahead. I here, j here, matching. I here, j here, matching. I here, j here, they're not matching, so the previous match was answer. That's how I'm going to do that. That is why I'm keeping the variable previous match. So I'm start putting two pointers in the end of both of them. Now while I is greater than equal to 0 and j is also greater than equal to 0, simple, if in the L1 ith guy is not equal to L2's jth guy, it means what? I have to return previous match, whatever previous match was there. Else it's pretty simple, they are matching, do I minus minus, j minus minus, and update previous match equal to, or first let's update previous match and then do I minus minus, j minus minus. Previous match is equal to nothing but L1 of I. Okay, now this is done, this is done, while loop is done. So the way it will work is again simple. I have a I variable, I have a j variable, they are matching, update previous match, go ahead, they are matching, they are matching, they are matching. Here I and j will not match, so what I'll do, I'll return the previous match. So answer should be return previous match. There will be some edge cases, let's just see those edge cases also. So what are the edge cases? Let's just say I have to get lowest common ancestor for these two guys. So in this case what will happen, I have for E I have EDCBA, and for C I will have CBA. My I variable will be here initially, j is here, match, I is here, j is here, match, I is here, j is here, match. Now then I and 0, j will become -1. So in case j becomes -1, what is the answer? Again, if when j becomes -1, answer is still the previous match, right? So that is why till the time j is greater than equal to 0 we are running, and as soon as j becomes negative, still the previous match is answer. The other way around is possible. Now let's just see one more. If both the nodes are passed as E, or let's just say both the nodes are passed as C, in that case what will happen? CBA, CBA. So I is here, j is here, match, I is here, j is here, match, I is here, j is here, match. Now the loop breaks, both of them have become -1. Even in this case the previous match is my answer, so I can return previous match, no edge case. Just wanted to show you. So hope it makes sense to all of you and you understood this. Now friends, we can improvise even this for a BST, okay? That I will do in a different question, but the LCA for BST can be calculated in a more easier way, because there we have some BST properties also with us. Thank you so much. See you in the next video.